Topic 16.4, distance on a number line. We've been using number lines. What we're going to do now is find the distance on a number line, primarily when numbers or integers are on both sides of 0. One good example to do that with is difference in temperature, when temperatures are above or below 0. Think of the coldest outdoor temperature you've ever experienced. It's usually in the winter or overnight. Remember, we usually deal with the Fahrenheit scale. So freezing is at a positive 32 degrees Fahrenheit. That temperature can still drop below freezing, below 32. It can even get all the way down to the 0 and keep on going. We don't really experience that, but in other parts of the country you do. So anytime it drops below 0, that's going to be in the minus numbers or minus integers. We're going to be looking at the difference between two temperatures. Let's say that at 5 p.m. one evening, the temperature outside someplace in the country was 12 degrees Fahrenheit. Then at 9 p.m., the temperature dropped. We'll say it's at negative 3 degrees Fahrenheit. How can we find out how much that temperature decreased? Alright, so I've drawn this number line. We've got it all set up. The number line is going up and down, kind of like what a thermometer would look like. And here we have the temperature at the 5 o'clock. That's at the 12. And then we have the 0 marked here. And then at 9 o'clock we have the minus 3. So you may want to pause this and make sure I got my number of increments correct. Just check me out there. Did you check? I did. It's correct. So we want to find how much the temperature decreased over that evening. So we're looking for the total distance. So that's going from the positive 12 to the negative 3. So do you see how a student might come up with 9 degrees? They'd end up taking that negative 3 away from the 12. So it's kind of easy if you're visualizing this on the number line. I always just figure out just looking at the 0 and just the distance that is from 0 to 12. We've got 12 units, right? And then going this way from 0 to negative 3, we get 3. So you just combine those two. So the total distance between those would be 15, or in this case 15 degrees Fahrenheit. It's very important, though, that you understand that when you're calculating this, if you're using a visual or a graphic, that when you're finding that distance and you're going to actually count it out, you do not count that actual point right there. You need to, like we're going to find the distance from negative 8 to a 5. Okay, that when you're counting these, you're actually counting the units. You start there and go 1, 2, 3, 4, 5, 6, 7, 8. So we've got 8 here, and then we should have 5 going this way. 1, 2, 3, 4, 5. So we got 5 going there. So the distance from negative 8 to 5 would be 8 units plus the 5 units to equal a total of 13 units. Now let's try just one more thing. Let's just say this is the 0 point. And what if I said I wanted you to tell me, 2 integers. Give me 2 integers that match this following description. 2 integers that are 6 units away from 4. So 6 units away from 4. Going in this direction, 1, 2, 3, 4, 5, 6. There's one right there. That would be, a positive 10, right? And then 6 integers the opposite direction. 6. That would be a negative 2. So 2 integers that are 6 units away from a positive 4 would be a negative 2 and a positive 10. You're going to see some of those in your classwork today. All right, so I got a couple of quick check problems for you over on the right, and give me your best answers on those, and I will see you in the morning.